All right, so in question one of the class test, this is a very basic sort of format of pretty much any first question. If you go back and look at past tests and exams, you'll see very similar formats for these. So we want you to be able to look at a skeletal structure and be able to work out its molecular formula. And really, this one was sort of C15, H22, NO2, and then the chlorine. You get your 2 marks if you got that exactly correct. All right, so this metallochlor, if you should be able to work something like that out. This wasn't done particularly well, I'm told. Just the functional groups, the recognition of that. We have over here an oxygen that's bonded to 2 carbons. That is an ether. And an ether functional group is not primary or secondary or tertiary, it's just an ether. And if you did put a primary, secondary, tertiary, you would have got a negative mark for that. And then over here we've got the chloride. And so if you wrote down chloride, you would have got your mark for that, but there was another mark associated with recognizing that's a primary chloride, and that was important. And then the ether group would get a mark. And then over here, again, people, you've got to recognize these functional groups. It's not an amine. It's not just a nitrogen connected to 3 carbons. Because of this carbonyl group here, this whole group is an amide, and that's what you needed to write for that. All right, how many lone pairs are there in metallochlor? Again, this is something unique. We want you to be able to look at a molecule and to be able to immediately see on each of the atoms where lone pairs are, where charges are, and things like that. So how many lone pairs are there in metallochlor? Well, there's 1 over there. There are 2 on the oxygen, and on the chlorine, we must have another 3 lone pairs. So 1, 2, 3, 4, 5, 6. And mustn't forget the oxygen over there as well, 7, 8. So you would have got your marks for that. How many conjugated pi bonds are there on metallochlor? Well, conjugated means alternating between double, single, double, single. So we've got double, single, double, single, double. It goes around in a circle, and then we go single, single. So this double bond is not conjugated to the aromatic ring. So all we have over there is 3 conjugated pi bonds. How many sp3 hybridized carbon atoms are there? The glyphosate. So now we're going to the other molecule. We're looking for sp3 hybridized, so carbon with 4 different groups on it. So that has 4 different groups: a phosphorus, a nitrogen, and 2 hydrogens. This has 2 hydrogens as well, so that must be an sp3 as well. That's got a double bond on it. Can't be sp3. All right, there's not many carbons there to choose from, so that one should have been very easy. If you struggled with that, you're struggling with some very basic things. You must go and study this. It's such a simple mark to get, knowing something like that. All right, so the next 2 questions had a negative marking associated with them, but together. So there are 4 marks in total, and you needed to have got, if you marked anything incorrectly, you would have lost marks for that. So the first thing is marking chiral centers on both metallochlor and glyphosate. So if we look at the chiral centers, we are looking for an sp3 carbon that has 4 different groups on it. Glyphosate, we've already established where the 2 sp3 carbons are, and both of them have 2 hydrogens. There's no chiral center in this molecule over here. So we have to go to metallochlor. It's got 3 hydrogens, 2 hydrogens, 3 hydrogens. All of these are out. It's got a double bond. It's not sp3. Cannot be chiral. This has 1 chlorine on it, 1 carbon on it, but 2 hydrogens. It cannot be chiral. 3 hydrogens over there. 2 hydrogens over there. Can't be chiral. 2 of the same group. 3 hydrogens over there. 1 hydrogen on this carbon, 1 CH3, 1 CH2O, and a nitrogen. There are 4 different groups on this carbon. This one over here must be the chiral center. There's no other chiral center on any of these molecules. You would have got 2 marks for that. If you had marked something else as a chiral center, minus marks would have been applied, and it would have cancelled out the answer that you gave. And then in question 1.7, you had to fill in the missing charges, and the only molecule that has missing charges is this molecule over here. Normally missing charges are associated on atoms like nitrogen, oxygen, sulfur, phosphorus, any of the heteroatoms. You should be able to pick those out very quickly. 3 bonds to nitrogen, it's fine. 2 bonds to oxygen, it's fine. 2 bonds to oxygen, it's fine. 1 bond to the chlorine, it is fine. 2 bonds to oxygen, it is fine. 2 bonds to oxygen is fine. 1 bond to oxygen, it is not fine. It must have a minus charge on it. 3 bonds to nitrogen, it's okay. Carbon, 4 bonds. 2 bonds to this oxygen, 1 bond to this oxygen, it must be minus. It's a simple thing. You should be able to see this very quickly without even going through like what I've done now. You should look at a molecule and very quickly just, okay, there I can see there must be something wrong, and that's where the charges are. And that would have been your other 2 marks. And in this question, most of you, or yeah, I'm told, have missed this, the point of this. This is just a one-step reaction, but it's talking about what happens when you use metallochlor with sodium hydroxide. And the point is there are actually 2 things that can occur. The one is a substitution of the chlorine, because that's a good leaving group, but the other thing is you've got an amide bond there, and that can also be hydrolyzed. And I think a lot of you missed that. So you had to formulate both products, and the products looked, so it's like this. Anyway, you can see it on the memo. I'll just draw those out quickly. And this is the last one. And just because we're doing this in base, you should have got the fact that it will be the O minus, and then this was substituted. All right. So, whoops. Sorry about that. Shocking. Right. So, carboxylate, because it was done under basic conditions, and that was the substitution for the chlorine, and where the OH went. All right, that's question 1.